This video is a lesson over perfectly inelastic collisions. Alright, so for this problem we have a block with a mass of 2 kilograms that has an initial velocity of 5 meters per second. And this block hits another block, and this other block has a mass of 1 kilogram, and that block is initially at rest. And so we have three things we need to find, and one is what is the velocity of the two blocks after the collision, what percentage of initial kinetic energy do the blocks have after the collision, and what is the total momentum after the collision. So here we're going to assume a perfectly inelastic collision and that there is no friction. Okay, so for these two, we know really a perfectly inelastic collision is really that one thing will be, well, I guess it could be two things that are moving, but what happens after the collision is that the two or how many ever things that are, colliding here, they stick together as a whole after the collision. So with these, we know that momentum is conserved, and that's for a perfectly inelastic collision that momentum is conserved. And another way to write momentum is that momentum is equal to mass multiplied by velocity. Okay, so let's start with the first question. What is the velocity of the two blocks after the collision? Well, if we know that momentum is conserved, we can say that the final momentum is equal to the initial momentum. And so if we expand that, the way we can write our final momentum is the final mass, which would be both of the masses added together multiplied by the velocity, so your final velocity. And that should be equal to the only block that has any momentum initially is the block that is moving. The other block that is initially at rest has no momentum because it's at rest. It has zero velocity, so a velocity of 0 would give you a momentum of 0. So for this one we'll say that it's that first block multiplied by that first block's initial velocity. So if we go ahead and solve for our final velocity, which is what we want, what we're trying to figure out, we'll just divide by mass 1 plus mass 2 on both sides, and we'll be left with the initial momentum divided by mass 1 plus mass 2. Now if we go ahead and plug in numbers and solve for this, we'll have 2.0 kilograms is what we'll be considering mass 1, and that initial velocity of that first block was 5 meters per second, and that's over the two masses added together, which is 2 kilograms and 1 kilogram. So you should get a final velocity of about 3.3 meters per second. And now, the next question is, what percentage of initial kinetic energy do the blocks have after the collision? So to find that percentage, really it's just going to be a fraction, and that fraction should be the final kinetic energy divided by the initial kinetic energy. And to make that a percentage, we'll multiply it by 100 and add a percent sign on the end. So we're really multiplying just by like 100%. So let's go ahead and expand that out. So the final kinetic energy is 1/2 multiplied by mass multiplied by velocity squared. So the final mass was the two masses added together, and then we had our final velocity squared. And then our initial kinetic energy can be written as 1/2 the first mass multiplied by your initial velocity squared. And again, I'll kind of just tack on this times 100%, so we remember to make it a percentage. Now, you can reduce the 1/2 on top and bottom because it is on the top and bottom of this. But after that, we'll just have to plug in numbers and to solve for our value here. So on top, we'll have 2.0 kilograms plus 1.0 kilogram multiplied by 3.3 meters per second, and that value is squared. And that's all over the 2.0 kilograms multiplied by 5.0 meters per second, and that value is squared. And again, remember to multiply by 100%. And when you actually do this, the units should all cancel out, so this should be unitless, which makes sense because this is really an energy over energy term. And so you'll get a decimal of about 0.667, but then again we're going to multiply to make it a percent, so it should become 66.7%. And that's what our answer should be. And then our last question is, what is the total momentum after the collision? So the total momentum can be just written as, the mass multiplied by the velocity. So our ending mass is the two masses added together multiplied by the final velocity. So if we plug in some numbers, should be at 2.0 kilograms plus 1.0 kilogram multiplied by the 3.3 meters per second. And what I'm getting that to come out to be is 10.0 kilograms meters per second. And that is actually the units that are used for momentum. There's not actually a derived unit like joules or something like that for energy. It's just kilograms meters per second. This has been a lesson over perfectly inelastic collisions.